circle has 360 degrees, and the semicircle is 180, and then you have to take a fourth. That's gonna give you 90, which is pi over 2, and then at 180 it becomes pi. It changes at 270 to 3 pi over 2, and then you're back at 2 pi at 360. All the other kids with the pumped up tricks, you better learn the circle. All the other kids with the pumped up tricks, you better learn the radians. All the other kids with the pumped up tricks, you better learn the circle. All the other kids with the pumped up tricks, you better learn the radians.
Wow, wasn't that just awesome? Thank you, Patricia and Katie, and I look forward to more verses as we move on through the wonderful world of trigonometry. All right, good evening, Bearcats. This is Chapter 4. We're beginning our big adventure into trig. We're going to first start with Section 1, radian and degree measures, and our objective will be that you know how to describe an angle and to convert between degree and radian measures. I first want to give you a little bit of information about trig. The word trigonometry it means the measurement of triangles. Some of the applications where we're going to be used, how it's used. We have it's used with sound waves, light rays, planetary orbits, strings, like the vibration of strings. So all of you orchestra people will know about that. Pendulums. I believe all you band people know about that. That's that little thing that moves back and forth. I know it's called a special thing in music to kind of keep the beat or start your beat. You have to explain that to me in class a little bit. And then, of course, the orbits of atomic particles, and that's going to be all your physics and chemistry and science classes. So all you future engineers will be using it to calculate orbits of atomic particles. All right, let's go on to a couple of definitions. You may want to pause this and write this down. I would have these in my notes. 1, an angle is 2 rays with the same initial point. We're going to give an example of that in a minute. 2, the measure of an angle is the amount of rotation required to rotate one side, which is called your initial side, to the other side, which is called your terminal side. I'll show you an example of that in just a minute. Number 3, the shared initial point of the 2 rays is called the vertex of the angle. Number 4, an angle in standard position, if its vertex is at the origin of the rectangular coordinate system and its initial side lies along the positive x-axis. I'll show you an example of that as well. Number 5, if the rotation of an angle is in counterclockwise direction, then the angle is positive. So counterclockwise is positive, which is what we'll mostly be doing, but we will also have some negative angles, and we call that, if the rotation is clockwise, then the angle is negative. And finally, number 6, 2 angles are in standard position if they have the same terminal side. They are said to be coterminal, and we're going to talk about coterminal angles as well. All right, based on these definitions, I want to give you some visual examples as well. So let's take a look. First, let's talk about just what our angle looks like. Again, if we lie along the x-axis, this angle will be lying along the x-axis. You can imagine this maybe even inside your unit circle. And the angle is a ray that rotates about an endpoint. Here's our endpoint, and this ray would rotate counterclockwise this direction. This angle measure is often referred to as theta. We also have different variables for this. This is just a variable for the angle. We often call it theta, but it can also be beta, alpha, some other variables that we'll come across as time goes on. This side right here is our initial side. Oops, goodness. Sorry, that should be really straight. Is your initial, oops, I-N-I-T-I-A-L, sorry, side. Pen's a little jumpy today. And this side right here is your terminal side. Okay, that's because we start with the initial side and we rotate counterclockwise, and that would be the ending where we ended, which would be our terminal side. And of course this point right here is your vertex. So just giving you some visual aids here. We can fit our angle into a unit circle. We talked about that a little bit, and we looked at that the other day. I don't have the best ability to draw freehand circles, but we'll try our best. And let's say this is our center, and let's say this is our angle. All right, and so again, this is our rotation right here. So we angles generated clockwise. This direction would be positive. And let's say we did this and we generated one going this way. This would be a negative angle. The rotation would be the same amount. It would just be negative because it's a negative direction. A negative direction. You can also look at it this way. Let's take it on a coordinate plane here. I also sometimes like to think of it this way. So we move this direction. This is positive rotation and positive angles. If we go this way, this is negative rotation or a negative angle. Both of these angles are in standard position. Let's go back and take a look at what that meant a while ago. Both of these are in standard position. An angle in standard position, look right here, is if its vertex is at the origin of the rectangular system and its initial side lies along the x-axis. So in both of these cases, that is true. They both lie along the x-axis. Their initial side here, this would be the terminal side, this is the initial side here, and this would be the terminal side. So both of these are in standard position. Both are in standard position. Okay, it's just important that we kind of know all the basics for this. Next, let's talk a little bit about coterminal angles. There was a formal definition earlier. I want to show you some visuals. They're angles that have the same initial and the same terminal side. So we talked about that. So let's take a look here. Same initial and same terminal side. So if this is my initial side right here, I start here, standard position. And this is my terminal side right here. Okay, so my angle is going to either rotate counterclockwise in a positive rotation to here, and we'll just call that alpha. Or it could rotate in a negative direction, this direction. We'll call that beta. All right, and so this angle is beta, this angle is alpha. Notice together they form a 360 degree or a complete circle. They both, though, started here at the same standard position. They both started at the x-axis. The initial side was the same for both. The terminal side is the same for both. This is our terminal side, just they're going in different directions. So in this case, these two angles would be coterminal. Coterminal. A couple other things we want to talk about is radian. It's the measure of a central angle. We've already really talked about this a lot when we did our unit circle exploration with the pipe cleaners. Often that angle is written as theta. Not the only variable that we can use, but often. And it intersects an arc. Intercepts an arc. And we're going to call the arc S, equal in length to the radius. And we talked about that when we did our pipe cleaners. So 1 radian is the arc that is equal to the length of that radius. So an example here would look something like this. Sorry about my poor circle drawing. Alright, so we start here with our radius. Our radius makes a rotation. This is also a radius. This is the angle theta, which would be 1 radian if this arc right here is the length of this radius. And that arc is referred to as S. In this case, S is equal to the length of the radius. It's just curved along the outside of the circle. So don't forget also that 1 rotation around our circle is 2 pi, but the song that was developed for us by Patricia and Katie certainly is a great reminder of that for us, as well as your pipe cleaner experiment the other day. Really like that song, girls. Be kind of catchy. All right, next let's talk about coterminal angles and sketching them. So we're going to continue coterminal angles. We want to insert a couple other pages in here, I think. Oops. All right, so when we do that, we want to sketch a coterminal angle. Here's an example. We want to sketch and find the coterminal angles for the following. So these are some examples. All right, let's take a look at this angle, or as this example. We're sketching and finding a coterminal angle to the given angle 13 pi over 6. All right, 13 pi over 6. Let's review a little bit. Remember, this is pi, which would be 6 pi over 6. This is 2 pi, which would be 12 pi over 6. So 13 pi over 6 would be up here in the first quadrant again. So this given angle right here would look something like this. We would start and we would rotate all the way around and then back around a little bit. And that would be our given angle 13 pi over 6. So this would be our 13 pi over 6. We want an angle that's coterminal. Remember we looked at coterminal angles a while ago. Let's glance back up there. Remember on coterminal angles when we looked at them, they started at the same initial side and they ended at the same terminal side, and therefore they made a complete circle. So keeping that in mind, for coterminal angles, we can usually add or subtract multiples of 2 pi, which is 1 full rotation, to find those algebraically or to visually look at them. If we visually looked at them, what we could have done is we could have gone a coterminal angle to this would start and end at the same place but be a different angle. Well, we could have started here and ended here, and that would have been the same. We would have had the same beginning and we would have had the same ending, and those would be coterminal. How could we do that algebraically? Well, in this case we could have taken this and subtracted 2 pi. So we could have taken 13 pi over 6 and subtracted 2 pi. Now you know that that would be 13 pi over 6, and we would subtract 2 pi, which would be 12 pi over 6. And the difference between that would be pi over 6. So, of course, this angle right here would be pi over 6. Therefore, we used to do this in geometry with the little triangles, little dots, and made a triangle. Therefore, 13 pi over 6 and pi over 6 are coterminal. What else could we have done? What if we had added 2 pi? Then we would have started here, we would have gone around, and we would have gone around one more time, and we would have ended back up in the same place. So we would have started here. It's kind of tricky. Kind of run around a room. We would have gone around, and then we would have had to add 2 pi more. All right, and when we did that, let's take a look at what would have happened. We would have had 13 pi over 6 plus 2 pi, which we know is 12 pi over 6, which would be 25 pi over 6. So 25 pi over 6 and 13 pi over 6 would be coterminal. We could have also subtracted multiples of 2 pi if we wanted a negative value. So I'm going to draw my picture one more time because that one's kind of messy. And remember, our original angle went like this on our circle. And if we had wanted a coterminal angle and going in a negative direction, starting at the same initial side, ending at the same terminal side, we could have started here and we would have gone around like this. And we would have wanted that negative angle. So to do that, we could have gone 13 pi over 6, and we could have subtracted 4 pi. So 13 pi over 6 minus 4 pi, I believe would be 24 pi over 6. And 13 minus 24 would be 11, negative actually 11 pi over 6. So negative 11 pi over 6 and 13 pi over 6 would also be coterminal. Okay, this initial angle was your 13 pi over 6, and because this went in a negative direction, this is a negative 11 pi over 6. All right, so there's a little example about coterminal angles. If you need to slow that down or look at that again, maybe watch it once without writing things down, you might want to do that. That's a very important concept. Let's try 2 more quick ones. And then remember, you're going to have some of these in class on a little quiz you're going to take on Monday, which is tomorrow. All right, so let's look at B, example B. We're given the angle 3 pi over 4. All right, let's see where that is. So 3 pi over 4. Well, we know this is 4 pi over 4, and this is 8 pi over 4. So 3 pi over 4 would be back here in the third quadrant. So our rotation would be something like this. Initial point, terminal point. And to be coterminal, we could have gone all the way around, or we could have gone backwards. So we could go all the way around and get another angle, which would be a positive angle. Or we could start here, and we could go in a negative direction and get a coterminal angle that's negative. So let's see what we would do in that case. So we could take 3 pi over 4, and we could subtract 2 pi, which we know now is 2 pi, which is 8 pi over 4. And if we did, we would have negative 5 pi over 4. So this negative angle would be negative 5 pi over 4. And that would be coterminal. These angles would be coterminal to one another. We could also add 2 pi. So if we add 2 pi, we're adding 8 pi over 4. 8. So that would be 11. And 11 pi over 4 and 3 pi over 4 would be our 2 coterminal angles. One positive coterminal, one negative coterminal. All right, so you'll have some of that to work on tomorrow. Let's take a look now at one other little concept. All right, let's talk now about complementary and supplementary angles. Angles between 0 and pi over 2 are called acute angles. So remember on our unit circle when we had that, we had pi over 2 up here. And so angles in this first quadrant would all be acute angles. all be acute angles. If it reached pi over 2, it'd have to be between them. If it reached pi over 2, of course, it'd be a right angle. Angles between pi over 2, I'm sorry, between 0 and, I'm sorry, that's not true, between, oops, let me see if I can erase that. Okay, so angles between pi over 2 and pi. So again, in our little unit circle, that would be between here. So between here and here, so in this area of rotation, somewhere along this side, would be obtuse angles. They're greater than 90 degrees, but less than, sorry, they're greater than 90 degrees, and they would be called obtuse angles, big angles. All right, two positive angles are said to be complementary, okay? And if you didn't learn this in geometry, I hope you did. Complement, remember, a complement is the right thing to do. To pay somebody a compliment is the right thing to do. So two positive angles are said to be complementary, or be a right angle if the sum of their measures is, and that right angle, of course, would be pi over 2. And they would be supplementary if their sum of their measures was pi. And that part you knew from geometry. That was from geometry. You just didn't use radian measure too much. All right, let's take a couple of examples here. So we're going to find the example 1, or our first example here. We're going to find the complement of 2 pi over 5. Well, if we want the complement, remember complement is the pi over 2. It's the right angle. So this angle plus an angle, so 2 pi over 5 plus something has to equal pi over 2. Well, we know we're adding and subtracting fractions, so the first thing we're going to do is we're going to have a common denominator. And of course the common denominator here would be 10. So we would have 2 pi, oops, sorry, multiply both by 2. So 4 pi over 10 plus something has to equal, and if we're going to make this 10, this would be 20 pi. Alright, so if we change this to tenths, we multiply 5 by 2 and the top by 2. If we change this to tenths, we multiply the bottom by 5 and the top by 5, so 5 pi over 10. And we need to solve for the blank, so we would have our blank equals 5 pi over 10, and we would subtract the 4 pi over 10, and now our blank now would be pi over 10. So pi over 10 and 2 pi over 5 are complementary angles. All right, here's a couple more examples. Let's find the supplement of 2 pi over 5. All right, if they're supplementary, they need to add up to pi. So we know that 2 pi over 5 plus something has to equal to 2 pi. We can put that over 1 if it helps us. Again, we would need common denominators, so both would be 10. And 5 times 2 is 10, and 2 times 2 is 4. So 4 pi over 10 plus something has to equal, and would be 10. 1 times 10 is 10, and 2 times 10 is 20. And if we want to find the supplementary angle, then we would subtract from this side, and we would have 20 pi over 10 minus 4 pi over 10 is equal to what we're looking for, our blank, and that would be 16 pi over 10, which reduces to 8 pi over 5. So 8 pi over 5 and 2 pi over 5, 8 pi over 5 and 2 pi over 5 would be supplements of one another. I am really sorry, I just made a mistake on this. It's not 2 pi, it's only 1 pi. So I'm going to try to erase this. Let's see if I can do that. I was going too fast. This should be just pi. So this should be just 10. And this is going to change our answers here. Alright, sorry about that. I looked at it and I thought, that's not quite right. Sometimes that happens, but you want to catch your own mistakes. Alright, so actually this would be pi, and pi would be over 1, and so this would be 10 pi over 10. And we would have 10 pi over 10 minus 4 pi over 10 is 6 pi over 10, which would be 3 pi over 5. That sounds better. So 3 pi over 5 and 2 pi over 5 would be supplements of one another. Alright, one more example. Let's find a complement again. So we want a complement of 4 pi over 3. Alright, so let's take a look at that. 4 pi over 3. Well, we know this is 3 pi over 3, and this is 6 pi over 3. So 4 pi over 3 would be here, be down here. Uh-oh, we have a problem. This angle that we're given is already larger than pi over 2. Remember, complements have to add up to pi over 2. This angle is too big for a complement. Oops. So we have no complement. It's already too large an angle. Alright, the very last little concept we're going to talk about today is the conversion between radians and degrees to radians. This is an important concept. You definitely want to have this in your notes somewhere, and we will be using it quite frequently. Now, a lot of your special angles that we learned about on our circle, and we're going to go over again in class tomorrow and probably every day for the next week or two, you're going to memorize basically all the basic common special angles, the 30, the 60, the 45, and all of its different counterparts in each of the quadrants. But sometimes we're going to have angles that are not special angles, and we need to be able to convert them. So this is all about conversion between degrees and radians. Conversion between degrees and radians. So first, let's go from degrees to radians. And I like to set this up a little bit like your stoichiometry in chemistry. I know for some of you kind of go, oh no, but it really is a simplistic part of stoichiometry. It's just a way of converting things, and it's something that will come back up again for you, I'm sure, in your science classes in college and in the future. All right, so the basic formula is our degree, okay, whatever our degree is. And if we want to cancel our degrees, we're working on a semicircle, remember. We're doing all this with semicircles. We would cancel it by putting the degrees in the bottom, so 180 degrees over 1 radian, pi radians. Okay. This is 1 over 1 because pi radians is the same as 180 degrees, and we would be able to make our conversion. So here's our example. Let's use 135 degrees. So we're going to take our degree, 135 degrees, and we'll put it over 1. And when the bottom, we'll put 180 degrees out of pi radians. The little degree symbol will cancel, and we will end up with, sorry, I'm going to run out of room over here, 135 pi radians, and at the bottom 180, and then we would just simplify that a little bit further, and 135 over 180 simplifies to 3 over 4, so we would end up with 3 pi over 4. 3 pi over 4. Alright, and then our last example, we're going to go from radians to degrees. I'm going to go ahead and use another page just so we don't run out of room. So now we're going to go from radians to degrees. And that same kind of thing, we're going to take our pi radians, but it doesn't always have to be pi, remember. So I'm just going to write the word radians because it could be 1, 2, 3. It could be 12.8 radians. It may not be our special angles. Our special angles all have that pi in them, but not all our radian measure will be that way. We talked a little bit about that when we did our pipe cleaner activity. And this time we would want to cancel our radians, and we're using the unit circle, so we're using a semicircle, so pi radians. And at the top we would want to convert it to, degrees. All right, and so we would be using this formula. So here's our example. We want to go from 9 pi over 2 radians, and we want to convert to degrees. So we would take our 9 pi over 2, and we would want our radian cancellations at the bottom, so pi at the bottom and 180 at the top. Our pi's would cancel. And then I'm going to do a little cross-canceling here as I continue, just to simplify my math a little bit. I know that 2 can go into 180 90s. That would be 90 degrees. And 90 degrees times 9 would give me 810 degrees, and that would be my degree conversion. So 9 pi over 2 radians is the same as 810 degrees. Okay, you really may want to go back and work through this and think about this, and we'll be working some of this in class tomorrow. Anyway, hope you all have a great evening, and I will see you soon. Go Bearcats!